Hello, welcome to my bench. Haven't seen much of me in the last few weeks, and that's because I managed to go through 2 years without getting it, but my grandchildren finally gave me COVID. That wasn't fun. Fortunately, I was all vaccinated, and I was just about to go get my booster shot. Unfortunately, I caught it. Anyhow, 2 weeks. I'm much better now. Still sound like I can't breathe. It's because I can't breathe. Anyhow, what do we got today? Well, we have an Optimod 9400 AM digital processor, broadcast audio processor. The guy says the magic smoke escaped. So I haven't opened this yet. I have no idea. I'm not going to plug it in. If the customer says the magic smoke escaped, it must have been quite a bit of magic smoke. So we're going to look at it together. He said the magic smoke escaped. He must have taken the screws out himself too, because there's lots of them on here. Let's get a little thing for screws here. Yeah, some of these are loose. I hope to goodness it's not all that digital processing junk in here. Kind of hoping it's just a power supply or something that gave up the ghost. Because if those D to A converters and A to D converters, they start burning up, or their associated goodies, glue, then you got some problems. Get out of my way, microphone. Thank you. Can you still hear me? Yeah. I've had a couple of these Optimods, the digital Optimods I couldn't fix. One of them got hit by lightning, I think. Had to send it back to them. One of them, the minus 5-volt regulator, shorted partially internally, and it put like 9 to 11 volts on the minus 9 to 11 volts on the 5-volt rail. Negative 5. It didn't do it any good. All right, there's all 400 of the screws, and here we are. Well, let's see what's in here. Well, there's its digital parts. That the AES. Yeah, they got that little AES board. Let's give it a sniff test here. Don't really smell anything. Not right off the bat. Aha, wait, right there. Right. Come on, bend the right way. Right. There. See that? That doesn't look healthy. Well, we might. Why am I not able to? There. Nah, not there. There. I have a very strange setup for my overhead thingy up here. Camera. It doesn't. It's got a universal joint sort of deal, and it It's weird the way it works, but it's the best I could do. Hang on, I got to do something here. That's better. Too much glare on it. That's going to glare. That's nicely reflective. All right, so we got to get this guy out of here, and he's held in by 900 screws. Let's see. It does look like this is going to be in the power supply. That's hopefully... Wow. There we go. Boy, that's tight. And this one back here. There we go. What else? 3 of these. Okay. And we'll hold you down. Well, let's see, there's a screw there. Yeah, that's a... Yeah, those are machine screws. Not like the other ones. All right, well, there's those 3. And, like, wow. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess they wanted to make sure that this heatsink didn't fall out of this box. These screws do not feel very tight. Gotta remember, these things are in service, and they're turned on and they're left on 24/7, 365. And the weakest link in any of these things is probably the power supply. Alright, so there's all 9 of those. Get you out of the way. Any more? Yeah. Is that just stuck there because of the heatsink compound? Yeah, I think so. Well, not completely. Got to unscrew this guy. The AC connector on the back. Well, one of those guys with a little filter in it. Alright. That feels okay. There we go. Ta-da! And okay, it's soldered over there. The ground wire, that is, and it's okay, fine, be that way. Where are you? Here you are. He's about that size? Good guess. Okay. Where'd you go? There you are. Yuck. Gooey. Alright. Get you out of here. And put you down out of the way for a little bit. And let's see what we got here. Well, we got a power supply board. And it's all self-contained, standalone, brute force power supply board. What? No switch mode power supply here. Alright, so what has it got? Well, let's see. Why are you standing up? Sort of slipshod. Hazardous voltage. Yeah. 680 microfarads. 25 volts. 6800 at 25 volts. Yeah. Alright, so it's got what on it? It's got, one of these days I'm going to find a decent. What is that? 7815. 7915 does not look healthy. And looky here, one of our friends, I believe that used to be a tantalum. Bet that's shorted. 7805, 7905, and a 2576 T5. Is that -5? I don't know. Very hard to read. Anyhow, we got blowed up tantalum, I'll bet you. Well, whatever it is, got to be replaced. That's not. And what else burnt? Did not burn through the bottom of the board. It just blew its guts out the side. And I wonder if it took that cap with it. I don't know. Let's find out. Okay. Put the magic ESR tester here. Okay, so we know this guy's going to be short. Okay. It's either short or really low ESR. I'm going for short. Alright, what are you? 0.49, 0.40, 0.48. Can you see this? Yeah. 0.47. Good. Big ones. Just in case. Snap. Oh, very good. 0.01. Alright. So, this guy's shorted, but we're not going to know if it took out that 79. I say 7915. That's 7815. That's a 7915. Alright, well, we'll find out. Alright. Still got little froggies in my throat. That little blue ESR tester is just a wonderful thing. Alright, so we'll take this cap kind of cooked, but well, there. So what's left of it? Alright, let's take, I don't think this is going to work, but I'm going to give it a shot. I'm going to take that electrolytic over here and pull him out too, because could have taken a serious hit when that thing went. Well, this might actually work. And of course I pulled the wrong one. Gotta tell you, I'm still not feeling 100%. I mean, I'm okay, but I still got a little bit of the tired's going on. There we go. You mark plus and minus. Yeah, you are. Okay, well, let's see what this guy says this value of this thing is. First off, I mean, we tested it in circuit and it was like 0.45 for voltage or for ESR. It says it's a capacitor, 107 microfarads at 0 ESR. Okay, well, 100 at 25, just for fun and giggles. Let's test it out of circuit here. 0.36, but .28. Well, it looks fine. However, we don't know what it's going to look like. I just don't want to take... See, when I fix this stuff for radio stations, I understand that this thing's going to go back into service, get turned on, and never looked at again. 24/7, 365. And I don't want it to go out because I didn't bother replacing a 57-cent cap. I mean, I might still, even though, I mean, I know that the blackness on the board was basically, take this down to 100 ohms, 100 hertz. And we're looking at 100 microfarads, 0.87 ohms, and an 86.88, minus 86.88 phase. That's fine. I'm still going to replace it. I just, you know, I don't know. It's just me. Of course, I got to find out what those tantalums are. And this tantalum, which is the same animal, is unfortunately exactly in the wrong spot to be readable. Well, I have a manual for this. Nope. There we go. Alright, so we're looking at turning this way. We're looking at C11. It says C16, C10. Oh, we're over here. Okay. So we're looking right here. Why you no see my... Well, sometimes... Anyway, C16. Right up where that thing just covered it. And what's its value? That's the little too much. So we're looking at the 7915 C16 2.2 microfarad at 35 volts. Okay. 2.2 at 35. I believe I have that. Hang on. Yeah. No. 2.2? 2.2 at 35 volts. No, I don't have one of those. We could do just a regular one there. There's 2.2 at 50. Nothing sacred about there's nothing sacred about a tantalum. I think they're cheaper. Alright, which way did you go in here? Plus went that way. Alright. In all respects, a good electrolytic is as good or better than a tantalum. Tantalums, the ESR is horrible. Anyway, they have more voltage per size, I guess. I don't know. I've never actually looked into it. I just know that not necessarily any better. 100 at 25. I have there's 100 at 25. Nichicon. I'm going to replace the one that, you know what? I took the wrong one out. No wonder it tested so good. Like I said, brain is not actually up to snuff right yet. So let us get this one out. Let's give him a test and see what he says he is. Yeah. I hit the wrong button. Hate it when I do that. Capacitor. 100 hertz. Yeah, this is the one that's cooked. Literally. That's 100, minus 86.5 and 0.89. It's fine, but it's getting changed anyway. Let's see if we can clean this board up a little bit. Well, it didn't burn anything. It just blackened it. Oh boy. Yeah, it just blackened it. So I'm not going to worry about that too much. $135. Fortunately, this thing's standalone, so we could just plug it in. And see what kind of current it draws. All right. We're going to take a guess that 7915 is okay. We're going to guess. It's a pretty good guess. Okay, well, let's get some of this stuff out of the way here. Okay, well, we got it all together. I'm going to take a wild guess that maybe this fuse went, considering that that thing did a complete dead short. Oh yeah. Poof. And fuses. Hang on. Okay, I'm back. Fuse. It's a 1/2 amp, 250 volts, slow bow. Anyhow, well, I was being an idiot before. This has got to go back in the box. So, let's put it back in the box. The reason it has to go in the box is because there's a transformer. I can get rid of this for now. Put you up where you live. Okay. We're just going to sort of tack this thing in here for right now. It just barely fits. Yeah, barely. All right. Get out of the way. Thank you. Come on. No, there we go. And puts a screw in it to hold it in place. That'll do for now. And we'll put the plug, it's off, in there, in there, in there. All right, now okay, this one, this one, and this one. Okay, they're all different sizes. That's good, because I did not take a picture of it. which was silly of me. I want this to go underneath here. And right to there. Okay. Pretty-ish. Whew. Okay. Let's change this. I got a 150 watt light bulb in there. I don't want that. I want a 60. Just in case. Alright, so everybody's hooked up. Alright. Got my little Vici meter up there. I'm going to say that's ground. I don't know if it is or not. And we shall crank the voltage down, turn it on, put it on current. Well, it is drawing some current. But I don't know if that's just normal. Let's see. $22 volts in. The light is on dimly. $12 volts, 15 volts out. Negative 12 volts. Well, looks like it's working. The out of the minus is 15. So let's test this. 15.3 negative. Good. This one 14.9 positive. 5 volts. Negative 5 volts. So we got all our voltages. The front's lit up like it's supposed to be. All right. We appear says on air. Can't see that very well from your position. So we're what? Network IP. Okay. So it appears to be working. Son of a gun. Alright, so blown up. What's it drawing for current? About 250 mils of AC. I think 29 watts, 300 mils of AC. Yep. Cool. That appears to have fixed it. Let's give it some noise. Let us take output of the generator, turn it on. Okay, generator's on. I want to go to left input. 600 ohms. I want output. Just want to make sure. Analog output left. And we will put that into the little scope. Alright, and I want channel 2 because I'm on. Alright. Turn it on. It's booting. And we have audio. So let's see. Input, left, right. I don't know how to do this. Oh yeah, it's working. So, get rid of the scope and show you the meters here as they flash. I'm going to turn down my input. You see everybody's going. Output's going up when I do. Gain reduction for left channel is doing what it's supposed to do. So, that's everybody. Now, we only got one other test to make, and let me set up for that. Okay, well, never mind. I was going to try to set this thing up for AES EBU, but that takes a whole lot of fiddling around in the front here, and I don't... there, fiddling around with the setups and things, and this is set up for analog, and I don't want to mess with it. But everything appears to be on. It's running. I did plug AES into it, and I got an output, but I can't switch it over so that we can see it or hear it without going through a whole bunch of stuff. And according to this, this is set up for analog. And I don't want to mess up their settings, and you would have to if you wanted to do that. So anyhow, it's working now. I'm going to put it on the burn-in bench and let it run for a while. I don't know, couple of like a day, and see how it does. But I'm pretty sure that that's what the problem was. That stupid tantalum just gave up the ghost. And you can see we have a non-tantalum cap in there, and it's working just fine, like I said. So anyhow, going to put it back together again, and like I said, put it on the burn-in bench, run it for a while, long while, and make sure that it keeps doing what it's supposed to be doing. But I'd call it fixed. So anyhow, hey, thanks for watching, and don't forget to subscribe and ring that bell if you want to know when I'm going to do more of this stuff. It's interesting stuff for radio stations. It's most of it's way overbuilt because of how it's used. You know, it's 24/7, 365, in service all the time. So anyhow, thanks for watching. Till next time.